My name is Jordan. I'm a member of the Microsoft Visual Studio team where I work on tools for JavaScript developers to build mobile apps. And I just mentioned our tools for Apache Cordova. That's the area I focus in, is in the Taco tooling. This includes tools that are in the Visual Studio IDE that many of us know and love, as well as the Visual Studio Code lighter-weight editor that many of us are also knowing and loving more now. And this talk is going to build upon some stuff we've looked at before, performance and the web in JavaScript. It's got an area loaded with, well, a lot of perception from people that when you go mobile with JavaScript, the apps are generally slower. HTML, CSS, and JavaScript, they have a reputation for being slow. And at least that's the perception people had. In this session, I want to dispel that a bit and talk to you about how you can make these apps feel more like a native application. Is there anybody in here actually who has that perception that apps are slow? Or you may be in here because you've heard that before and you're kind of curious about this. Okay. Well, you might have caught my style a little bit here. I like it if we can make it a little bit of a conversation amongst friends and technologists, so feel free to interrupt me as we go along. We'll do some Q&A at the end as well, but I'm happy to take some questions so that the thought doesn't leave you too quickly as we go through. Now, if you have not heard of Apache Cordova before, because a number of you haven't necessarily heard of it, it sounded like, let's touch base on the basics and level set on what it is. So Apache Cordova is an open source project. It actually started, I'm going to forget the dates now. It's been a while. Like 2009, a company named Adobe created the PhoneGap product. And later on, that becomes acquired by Adobe, and Cordova spins out as the open source project behind PhoneGap. So PhoneGap is Adobe's commercial fork of Cordova. Cordova is that same base layer. And what Cordova lets you do is take your HTML, CSS, and JavaScript skills to build mobile applications. And while you're doing that, you can also get at native device capabilities. So it's not just running a website in a mobile browser where you're limited to the browser APIs given to you to get at device capabilities. They actually have a plugin model that you go through. So if we look at a real high-level diagram here, the way you can think of a Cordova app is it is a native application that is wrapped around a web view or an embedded web browser. And that web view lets you talk to native device capabilities using something in Cordova called plugins. And what a plugin is it's something that somebody created for you. It's got a common JavaScript API you use in your code, say to get at the camera. And then somebody, the plugin author, has done the work of implementing the Java for Android, Objective-C or Swift for iOS devices, maybe C# or it could be JavaScript for UWP Windows devices, the native code to work with the camera, and you just worry about the one camera API, the JavaScript code that you're going to call through in your application. And in a nutshell, that's how a Cordova application works. When you do a build with Cordova, it does all the work to package that content, and it's going to spit out an APK file that would be deployable through the store for Android, or delivered into your enterprise through a solution like Intune, an IPA file for iOS, and an AppX file for Windows. Now let's get into the meat of the performance talk. So we say a lot about building apps that are fast and responsive. Well, what does that really mean when you get down to it? And here's a view of how my team looks at it, of taking a number of sources out there in the industry on different ways people talk about performance and animations. In our team, we've used interaction classes. And a way you can read this, if you look on the left hand here, you'll look at a category of up to 0 to 17 milliseconds. Something happening in that time frame is considered to be fluid. Those are the animations. You do the math on this, it gets you those 60 frames per second you may have heard about before, which is what we want in really fluid, smooth motion for an animation. Instantaneous, that's 17 to 100 milliseconds, or maybe 50 milliseconds is that sweet spot. Those are more of the interactions, like when you go to touch a button or swipe something in a list, you expect the system to respond. They feel about, in that time frame is what you look for. And the 100 milliseconds to 250 milliseconds, things happening in that time frame, that's like whole page transitions. Those are things that you still expect to be fast. Anything above that gets more into the space of maybe you want to start considering putting a spinner on the screen because you're doing something more intense like loading data, doing some data processing, something a little heavier. What we focus on when we're looking in performance in our talks, this one today as well, is this first area here up into the 100 millisecond space of how do you have JavaScript apps perform fast, fluid, instantaneous. The There's not generally much question that JavaScript can handle the other stuff above that in the web browser. We're not too concerned that JavaScript can do these things. But anything in that lower range is really what you're focused on. Now I can put this into a two-part session. The first part I'm actually going to refer you, and we're going to build off of this talk from our Build conference a few years back in a talk called Getting Great Performance Out of Cordova Apps. And this one was a deep dive into the different elements of performance of a web application. Long story short, we talk in this presentation about this first, an assumed web view tax. So what is this extra tax I pay on top of a native app for the web view to be loaded in my application? And there's definitely a web view tax. You have a web view opening up, so there is a little bit of a tax. You have this other thing that then your content loads into, but we're not talking of something that takes a whole lot of memory or even many seconds on startup. That's more of when that comes in, is it may eat up some more memory and it varies by device. Worst case, you maybe get a 3-second delay in the startup of the app in some situations. But really, the big piece that the users start to experience is after that web view is loaded, what about these different interactions in my application? Does scrolling feel awkward? And so this presentation went through and it talks through individually all sorts of different points about good and bad behaviors and tips and tricks. And so I'm going to walk through these real quick right now. But admittedly, this starts to get into borderline 300 level, 200 level, like mixes the content a bit. So I don't expect you to come away with oh, that makes sense as I talk through each of these bullet points. But I'll refer you to that other presentation that really takes some more time to walk through them. But let's go through these real quick so you can kind of hear the advice we talked about before, and if it piques your interest, we can talk more afterwards. First, one of the bits of advice we gave from that talk was that your UI is considered fast when it reacts to user actions in under 100 milliseconds. So that's what we talked about a moment ago with those interaction classes. Another big one is about the number of elements on your page. So the fewer elements you have on the page, the faster the app can run, the less memory the app is taking up. And what I mean by this is, for those of you doing web development, there's the DOM, the document object model. So when you view your web developer tools and you got the hierarchy of divs and paragraphs and buttons and all the elements in there. The more elements you throw into that DOM, the more memory that's getting used up and the slower your app can become. And there are tricks like virtualization, which we're going to come back around on, that it does stuff to help manage the size of the DOM and keep it in control, but still let you make an app that looks like it's got a lot of elements going on, a lot of interactivity. Also had some tips around batching the layout operations. So a quick way to describe this is something you can have to look out for called layout thrashing, where when you change your settings in CSS, so the styles of the page, when you change those, that's going to affect a redraw of the layout of your app. Well, if you're writing code that's doing a lot of reads and writes, if you're doing that in a loop, every time you do a read, it needs to look at the latest values. And so basically you get in a state where the code is writing and reading repeatedly, and it's doing a lot of thrashing and redrawing the layout of the app. So you'll want to do things like do all of your reads first, do all the write actions second, and you get like one layout kind of readjustment. There are little tips and tricks around that space. They get into some really good depth on that topic. Some other things around CSS. I was excited when CSS came out with gradients and drop shadows because I used to use image tricks all the time to simulate those in my website. Well, it did turn out that the images could still be faster than having CSS draw those, and our theory was that CSS, when it has to animate and render a drop shadow or gradient, it's got to do more calculations, and it's actually having to do more of an animation loop than just taking an image that's already built and doing some work with it. The more important one, though, is this one here about transforming and moving elements on your screen. So instead of animating manually and changing the X and Y position of something on the screen, you want to use CSS and their transforms to move stuff around, because that actually runs outside of your JavaScript loop, which there's basically one of those you get. So you move that off to the GPU and you get a much more efficient animation thing going on. In general, CSS, there's also this request animation frame trick where you can have some JavaScript run before CSS writes to the screen. And the last of the points we talked about were around events. If you're working with elements in the DOM, basically we can tie all these together here. If I have an element that I'm adding to the DOM dynamically and I'm removing it, you want to make sure you remove your event handlers as you go with it so they're not building up and using up memory. If you are, say, doing a list of buttons and you had 50 buttons, it's more efficient to It's less efficient to put like a click handler on each of those 50 buttons than it is to put a click handler on a parent element wrapping them like a div, and that handles the clicks for each of the buttons. So the important thing is you don't have to remember all these things right now. I kind of wanted to touch those for some of you that may be interested in work at that level. But what we're going to talk about today with Ionic actually saves us of having to really think of some of those things. But a real point from that talk was that in the end, yes, we validated anyone can write a slow application, but you don't have to if you know the tips and tricks to follow. So building from that, we also find that the user perception about HTML and JavaScript apps being slow doesn't come down just to performance alone. It's also about the user experience. So whichever tribe you subscribe to, whether it's an iOS device or Windows Phone or Android device, you expect your apps to look and work a certain way. You're used to animations and text looking a certain way. And if you're running an app that doesn't quite fit your expectation, that's when apps start to get dinged on their ratings or people complain about their performance. So design is also an important piece of this. And this is really where a framework like the Ionic framework comes in. And what Ionic does is it gives you UI components you can use for building your app. And they take care of adapting the UI to those different platforms for you. So working with Ionic, they not only give you that UI piece, they also give you prescriptive guidance and design patterns you can use for building your app because it's built on top of the Angular framework. And so that brings with it not just a control library, but a way of building your applications. And this is what we're going to focus on today because it really hits that point of they've looked at all those items I talked about for tips and tricks. They've taken care of it in the Ionic framework to handle those for you, so you don't necessarily have to think about GPU and layout and request animation frame and handling all those things. That can take a lot of work to build that out yourself. When they've done that work for you and they've done the work to adapt to these different UIs, it's a great starting point for working with building out these applications. So go ahead, what's the question?
Have they moved it out, or have they implemented Angular 2?
Ooh, I love that question. So the question was, have they implemented Angular 2 yet? Yes. The version of Ionic we're going to look at today is Ionic 2, which is built on top of Angular 2. And even more fun to me is that these guys are actually today working on putting out their RC of Ionic 2 pretty soon here. And I'm going to be showing you that version of it. So we're running on top of Angular 2, the RTM release version of Ionic. Sorry, RTM release version of Angular. I'm not scooping the Ionic team. They're not RTM yet. They're not released yet. But Angular 2 is out and final, and this builds on top of that. So beyond the piece of being performance obsessed, they do adjust to the design patterns of the device you're running on, but they also have built this framework with lower memory consumption, lower CPU processing in mind. They had Ionic V1, was built on Angular 1, and it's been around and very successful. Lots of people using it. They took their learnings from that now in creating Ionic 2 and adding more capabilities to adapt to the look and feel of the platform. So they've been able to build upon this knowledge they already had about building a well-performing framework and extend upon it. Another benefit to Ionic is it is just built on Cordova. Ionic is not a fork of Cordova. Ionic works with Cordova. So you use the Ionic tools to do a build, and it's having Cordova do a build plus adding in some of their own stuff. And why you should be interested in Cordova is that it's actually a very active and mature ecosystem. It's got an active contributor base. Microsoft, Adobe, IBM, and many others are contributing into Cordova. It has, when a new version of a platform releases, for example, it typically can take maybe about a month, and then that platform support is in. It's also got a set of enterprise-ready platforms, plugins, and quality control. And what I mean by that is it's been used in enterprises. It's being validated by our team and others to make sure the plugins meet common requirements like security, authentication being a piece of that, secure data storage being a piece of it, things enterprises typically need, and you can do that with Cordova. And then through our team's tooling, we like to think it is better with Visual Studio and Visual Studio Code. Ionic 2 specifically, and Angular 2, use the TypeScript programming language as the main language you write in. And this is just a language that compiles down to JavaScript, and we'll look at that in a little bit here. But with TypeScript, you can get some better tooling through IntelliSense, and the ability to do some things like rename, refactors, items you may have used in other languages. So let me give you a quick demo here of what an Ionic application looks like. So we can see first how it adapts to the different design capabilities. I'm going to start with an Android device. So the application we're looking at is a conference application that the Ionic team has built to demonstrate Ionic 2. And so you can see here, this is typical of maybe other conference apps you may have used where you can scroll through a list of sessions, as many of you may have done today. Take a look at where they're going to be located, what time. You can see some interactions here. The animations match with material design. I can swipe and favorite a session. As I change on these different tabs here, I don't know if you can see it too well on the screen, but there's a little ripple effect from material design about the side of the tab I click on. It's animating that so it has a feel like the right design language. They have toggles that match again with the system. I can cancel that. Support for cards. And you can see here, I think the animations are pretty smooth as we're going through here. In a lot of ways, to me, this feels much like other native apps I've used. So I can scroll through my list pretty quick. So that's the Android look and feel. Now let's take a look at the iOS side. And you will see the same kind of content here running on my iPod Touch. And I can scroll through, and there's some specifics to Apple's design language. If you notice, the time is sticking to the top of the screen as I scroll. So I go through, and it has more of an iOS look and feel to it. I pick elements here. The animations go from left to right instead of top to bottom. My tabs look more like iOS tabs. Same with the toggles. And a drawer. And the icons are even changing a little bit to fit the design language, so they aren't the exact same, let's say, icons set on the side there. And on Windows, it's the same thing. You'll have, it adapts to the, like a Windows 10 with UWP apps, that look and feel, hamburger menus, some kind of navigation that adapts to the right look and feel of the OS as well. So at runtime, this is what's going on with our apps. I've alluded to some of this, but what's happening is when you're running your application, the UI, your code is going through Ionic. Ionic's giving you those UI components you're working with and some other helpers. Angular is the framework we're going through for how it's rendering components on the screen and handling some of the guts of the app, if you will. That's all running inside of an embedded web browser, so that's running on Edge on Windows devices, Chrome on Android devices, and WebKit on iOS devices. And Apache Cordova, when the app is running, Cordova does very little other than giving that glue for the plugins to work so I can get back to my native device capabilities. Oh, here's a little lower, like double click into the performance elements of Ionic 2 and where we say it's obsessed with performance. So it's built on top of Angular 2, which is built for modern browsers. They've improved the way they work with the DOM. Their data binding is more efficient than in previous versions. Ionic gets to take advantage of all those things. They also, in their code, are very, very cautious of working with the DOM. Like we had in our tips from that other session, you want to limit how much you're putting into the DOM and how you interact with it. And they're very smart that way. I talked with their developers, and they even go so far as to comment when they have to work with the DOM to make it clear to anybody else, like this is why they're doing what they're doing. It's with intent. So they watch that very closely. Animations, they get that on the GPU. They're using CSS and the tricks you need to have animation handled by that graphical processing unit on your device instead of using the JavaScript thread up. And that also gives them the benefit of things like 60 frames per second page transitions. And they're testing these behind the scenes for all of us as well, so we don't have to worry about that level of detail as much. That's their framework testing and processes. For working with lists of data, some of you may have used web applications before where you can tell that the scroll functionality isn't real. It's like there's a fake scroll going on. You used to, in a lot of places, have to imitate scrolling in JavaScript because the browsers didn't have native scroll events. They didn't tell you that there's actually a scroll action going on. Newer devices are, I think, I can't quote the version number, but for a few Android releases now and iOS releases, you could implement native scrolling and have real scroll events going on. Ionic uses those when they're available so that your scrolling is not simulated. It's an actual scroll from the OS. And they use list virtualization, which we'll just dive into that in a moment here in another demo about what that is exactly, but that helps increase the performance of scrolling when you've got large lists of elements on the screen. It keeps you from having, say, 20,000 DOM elements in the screen, which really slow down the app, and it can handle 20,000 rows of data still, but do that in an efficient manner. And then when you get down more toward building out your app for, say, release, they can take advantage of some things from Angular 2, such as ahead-of-time compilation. In short, what that is it's just some compilation now that when you'd run your app in the browser before, Angular could take these templates and things you're defining for how you want maybe items in a list to appear, and it would parse those and compile those as the app is running. That can be a lot slower than actually being able to compile in advance, so that when your app runs, it's just drawing out elements on the page instead of having extra processing going on. Angular is able to support this now, this optimization that Ionic can take advantage of. And along with it, they have the ability to do some optimized release builds, so I can actually do a production-style build that is optimized more than what I've been developing with. So they've got some fine-tuning they do for us. So for our main demo today, I'm going to go through, and we're actually going to go to how you would create an Ionic 2 application. We're going to take one of their starter projects, and I'm going to start turning it into a little bit more like the conference app I was showing you by bringing in some tab functionality. This one today is originally from one of their nightly builds, so I will just give that a caveat of it being right by their upcoming release that they have that they're working on, but there may be some edges. So I'm going to live a lot in the terminal today, but you'll see me using the Visual Studio Code editor to do my work, as well as that's using our Cordova Tools extension for some support of Ionic and Cordova in Visual Studio Code. But largely, we're going to be a little more through the terminal for some things because our extension doesn't have full support of everything that was coming in this new build of theirs. Is everybody able to see that okay, or should I up the fonts a little more? Okay. Okay, so what I did first to get set up, I'm not going to make you all sit through this, but what I did to get started was this machine is set up with a couple of things that I installed through NPM. So this is the Node Package Manager. This is a way you install a lot of tools as a JavaScript developer now. When I run this, it's going to go out and it's going to download this. This could be similar to NuGet if you're familiar with that, of having packages of stuff you're bringing down. I bring down Ionic and Cordova. These are going to give me command line tools and the stuff I need to be able to build my app with Ionic and using Cordova. So I've already run that. That can take a while to download and install. I also have installed on here Xcode, which is what I need to be able to do iOS development on a Mac. If you were working with Visual Studio and, say, Android development, our Visual Studio tools handle that installation for you. So if you're a Visual Studio developer and you chose to use our Apache Cordova tooling, we install Node, NPM, and the Android SDK if you need it, so you don't have to do these little bits of setup. Those are taken care of for you on that side of things. The other item I did here was, to start this project, I used their command line utility, Ionic, and I created the way you do this right now with their CLI is give it a v2 flag. And I had run this command, which again I'm not going to run because I just don't want to slow us down waiting for a download from the internet. But this command created a folder for my app named My Conference using their side menu template. Which is, I'm in the folder for my application now, so I can use their command line again and say Ionic serve. And what this does is it does a simple local development only build that's going to run in my web browser. So I don't have to do a full build for iOS, but I can preview all of my web code and work on my app just in the web browser to get started. So I'm saying Ionic serve. It's going through some of their build steps. It'll open up my browser, and now you can see the application. I'll zoom that one in a little bit. And this is their side menu starter template. Now in Visual Studio, we have templates you can get from the gallery. They aren't updated to this version of Ionic 2 yet. They're on Ionic 2 Beta 10. But they have, for example, this side menu, a blank, and a tabs template. So you could go in Visual Studio and do a new Ionic 2 side menu application and bring up an app that'll look like this. We're going to update those templates before too long here to be with the newer release of Ionic 2 as it comes out. But this template is really simple. It's 2 pages and a hamburger menu there to bring out a drawer and switch between my pages. And it has a list of items that just let me click on down into them and navigate down the stack and then back out. It's just a hard-coded list of items they put in here just to give you an idea of a very simple application to get started. What we're going to do is change this first page and put some tabs into it and we'll just put that list of items on that first tab. If you can think of it as that conference app, our first screen was the list of the schedule of events for the day. So we're basically moving to have a list on the first screen, and we'll add an about page as well. So I'm going to switch over here, and we're going to open a new tab. And I'm just going to open up Visual Studio Code. Okay, the fonts on our text editor will be a little bit bigger, but let me show you first just the folder structure that Ionic is using. And this is fun too. There's actually Visual Studio Code just recently put out support for icon themes. So I've layered in one here called SETI for the icons. So I kind of like having a little more color in my icon list there. So what the Ionic tool did was it laid down the application like this and brought down the dependencies I needed. When I did Ionic serve, it just ran the app. The structure of an Ionic 2 app now, really, the main thing you care about is this SRC folder. And in here, this is the core of your code that you're working on. Index.html is going to be just this thing you actually don't really pay much attention to. This is just, let's say, the bootstrapping page. This gets loaded first into the app, and then it's set up for you to do all the stuff Angular needs to do to bring up your app. Ultimately, that means it's going to load in this app.html file that is your home page. If I scroll over there, we take a look about this content. In here, this is where the Ionic UI components are being used. So I've got an Ion menu. This is what defines the menu, that drawer that's sliding out. And in the header, this is what's giving us the title of the page, and this sets us up to have that little hamburger menu on the side to switch into the drawer. And here, this code is going through a set of the pages in the application, and it is loading them into that list. So I get 2 buttons that let me click into my 2 different pages of the app. Now, where some of that, so this is mixing a few things here. I'm not going to dive into Angular 2 too much, but the ability to do these custom tags here in your markup, that is coming from being able to use components in Angular 2. And so Ionic has defined a number of custom components to step in where the browser didn't have native controls, like tabs, for example. And that's other items in here too where you can add custom attributes and extend upon these components for your application. This in Angular here, this command is telling it to iterate over a list of items, and it's using the code here is basically saying assign to P each element in that pages list. And so for each element in this list of pages, it's writing out a new button on the screen. Now you might be saying, where does pages come from? The .NET developer in me likes to think of this as code behind. It's not quite the same as when you think code behind like with the old web forms model, but you do have some code running along with that page. So what you see here is I've opened up this app.component.ts. This is actually the file that is representing the main component of our app. Our home screen comes from here, for example. So this is TypeScript code. Is anybody here familiar with TypeScript? Before I assume too much. Okay. So TypeScript is a language that will let you, it's what we call a typed superset of JavaScript. It lets you use some of the future features of JavaScript plus types. That's like saying a variable is of string is a number. JavaScript typically doesn't have types like it does in C#. TypeScript adds in types and also language features to let you use the future of JavaScript today in your code. So I write this code using TypeScript. Things like this line you see here, these are using a new module syntax for JavaScript that is coming into browsers now even. TypeScript lets you use it now, and when you are compiling your app, it turns it into JavaScript that can run in today's browsers and devices. So it's sort of, in some ways, a stopgap, also adding new functionality like types, language features that aren't even specified for JavaScript quite yet, like this thing called a directive. So suffice it to say, think of these imports kind of like using statements with C#, and the directives kind of like attributes. What this is doing is it's adding extra information to my class called myApp, and this info is saying this represents a component, and the HTML for this is coming from app.html. So Angular has some code in the system there that said it was going to load up myApp as the main component, and through this syntax it knows that app.html is associated with that code, so that's how it loads up our HTML file. This class is where it defines things like that list of pages that we're showing in the UI. So there's a member variable that is declared here to be, it is an array that has these objects in it. And the constructor of this class is setting up that array of pages. Okay. So what we're going to do now is I'm going to take and replace our first page and add in tabs into this screen here. So we're going to get rid of the starter content that said, to get started, do this, and we're going to add in some tabs. So for that, I'm going to use the ion tab component. And we're going to start with just defining, actually I'm going to use the ion tabs. And we're going to define one tab to start. Make sure I have my little cheat sheet handy so I remember the exact name. So with Ionic, I can do a few things here, like specify an icon. We're going to use a calendar for our schedule list. I can give it a title. This is one of those things you'll notice that the IntelliSense isn't matching the attributes I'm using yet. That's where we still have some work. The IntelliSense comes from our Cordova extension, but it's more for Ionic 1. So we're going to be doing some work to support the Ionic 2 syntax. Schedule. And then we'll do this thing that defines the content, the component associated with this tab. All right. So now I've said I'm going to have tabs. It's going to be one tab named schedule with this icon, and it's associated with this tab 1 thing. We haven't defined what tab 1 is yet. Oh, did I miss one? Thank you. I always love my coding assistants when they're in the room. So what we're going to do first is I'm going to use this import statement and bring in, so if you look at my folder structure here, page 2 is what I actually want to put on tab 1. I'm sorry, the indexes might be a little confusing. Page 2 is that list of items. I want to bring that into the first tab. And so to do that, I'm going to bring in page 2 from that spot. So I go up a level and back down into page 2. Now I have imported my page 2 component, and in my class here, I can say that tab 1 maps to page 2. If I save this, behind the scenes, that Ionic serve command has been running and updating the browser as I'm going. So it's going to pick up the change I just made here in a moment and load it into the browser, and we should see our session list. And so there I've got, let's be risky and up the font size. There I've got my tabs now brought into that front screen, and the content from page 2 is now showing on page 1, even though it actually is still a separate page as well. So let's add a second page here. We're going to add an about page to the app. And this is another thing in Ionic. I'm going to use one of their generators to first do the scaffolding of this. So I'm in my app. I can say Ionic G page, and I'm saying create me a page, and I'm going to name it about. And that will run pretty quickly. We look back, and you may have seen the screen update. It added to the pages folder this about page. And now I have a very simple stub of a page ready for me to put content into to load into my app. About me. We'll give it some content. And as of the release right now, and I'm just going to work around one thing in Ionic that they don't, in their scaffolding, they don't auto-insert a few things you need with Angular 2. So there's a little bit of a lag here. But basically, Angular 2, you have this module that defines your app's structure. I need to add into this module saying that I also use this component, the about page. I'm just going to add them in here. I'm going to import about. And I'm going to tell Angular that these are a thing. Okay, so that should add our about page to the app. I'm not referencing it anywhere, so there's no way I can actually get to that page in my application yet. So we're going to add it to our tabs here back on page 1. And I'm going to just copy this line. And we'll give it a new icon. And we will go in and we're going to change this code again to map to that. And I'm going to take and import now our about page. and map it to that tab. So I've saved my files here to the Command S here on the Mac. Save the changes. Ionic serves command is going to be watching back in another tab here. It saw that my files were changed. It ran it through their processing, updates the app out in the browser for us. The browser is going to refresh here in a moment, and we will see our About button, unless I had a typo in my code somewhere. There we go. And here is our About button. So now we're on our way to having that conference app. Now we can start, there's a little bit more to do to get the UI quite right. But maybe that gives you a little feel for the developer workflow. I'm using TypeScript as my programming language. I'm using Angular to define those components that make up the app. And I'm using Ionic's UI components to set up things like tabs. In this case, it's mapping to the iOS look and feel here. If I ran this on an Android device, it's going to adapt to that material design. So let me show you one last element to give you an idea of working with Ionic code. If we look at page 2 real quick, this is where we're defining that list of items. What's going on in here is that this Ion list component is being used to define the list, and a button is being put on the screen for each thing in this list of items. And so you can see here they're setting up an icon that they pull from that item. They're bringing in the title of the item as well as some notes about it. So now I was mentioning templates earlier. This is a template here in this code. I'm using these placeholders to refer to a value that later on is going to be pulled from the JavaScript code and put into the markup. And that list of items in this case is a pretty simple array of just icon names from Ionic, and they just add up in this code. They're adding to a list each of these items in there, and then that page back there is going to render them out. So that was sort of a little bit of a whirlwind tour through some things with Ionic 2. Let's continue on the path of some tips and tricks around working with Ionic and other things you as a developer will want to consider to help get the most performance out of your app. So one thing was Ionic 2 is taking care of a lot of those first sets of tips and tricks that I quickly recapped. They handle a lot of that for you in the framework to really give you some nice performance of your app. On top of that, there are a few more things you can do to also improve the application yourself. One of those, I've been hinting at this a bit, is virtualization. And so virtualization, this helps you with fast list scrolling. Many of us work on applications that are lists of data, and you want those lists to move quickly and be able to get through a lot of data. On the mobile device, you don't do pagination so much as you do scrolling. So you want that to be smooth and still be able to go through these big lists without your users really being hurt by it. So what virtualization does is it makes sure that your app only fetches what it needs and displays what it needs when it needs it, rather than specifically, in this case, for like a list. I could have written code that has 1,000 items on my screen, but I'm only going to show you 10 at a time. That's really inefficient, versus virtualization will maybe have 20 items and it shows you 10 at a time, and it handles reusing those items and loading new content into them and swapping it out for you as you scroll, doing a lot less putting new stuff into the DOM and just reusing elements. And it handles that for you, which is nice because it's really hard to write virtualized code yourself and make a virtualization feature. That takes a lot of work. So I'll give you a demo now of list virtualization and how you use that with Ionic. For this one, we're going to look at, I have adapted our conference application to use real data from this conference, and we have many more sessions than that little sample app had. So let me show you first what happens when our application just tried to work with that much data. So here is our application. I'm just going to start scrolling through the list. I'm actually trying to scroll through the list, and you're seeing, in this case, it was a happy accident that iOS really, through Ionic, couldn't handle the amount of data I had there quickly. Now it caught up, and so it's scrolling through the items, and things start to get kind of bad here. Part of this it comes from I didn't do any like paging of the data from the server side. This is a static list of content in a JSON file of all like 1,300 plus sessions. So it loaded all of them in at once, and so you can just see the performance there. So for a quick test, I thought, well, can I simply just use virtualization to speed that up for me? And luckily, it did turn out that I could do that. Let me show you what this looks like. So here is the code right now in the conference app used to list out our items. Make sure I'm looking at the right item. Our Ion list is here, and it has this code that cycles through all those groups of sessions. The groups are the chunks of times that then have sessions inside of them. And so this was looping through those. So if I had 1,000 groups, I get 1,000 of this code running and writing out in the browser. So the way I can change this up is I can actually go up to my list and tell it to use virtual scroll. And in here, I say that I'm going to scroll through this collection called groups, which means this code goes away. And so now the virtual scroll takes care of iterating through these things. And for my group here, I just tell it that it is going to pull its content from a virtual item. And I say let group. Let is like the var keyword. It just has some different meaning to it. So it's basically saying, define this variable called group. That's what the item is going to go into. So I'll just save that change, and I'm going to click and run over on my iOS device. So this is using our Cordova Tools extension to VS Code. When I clicked play, that ability to go to a device, Android device, emulators, our extension adds that into VS Code. And what you're seeing here is it's running through Cordova, and right now it's taking my content. It ran it first through a build of Ionic that does some stuff of translating the TypeScript to JavaScript. These files that are SCSS extensions, it's a language called Sass that compiles down to CSS. Compiles those, pushes it into Cordova, then Cordova does the work of putting it into that native app, building it through Xcode, pushing it to the device. And now our application is loading up on the iOS device. It's slower because I actually have that big JSON file with all my content in it. So in reality, you'd want to maybe delay the load of your content, pull it from a service. So ignore the startup time. The important thing is, as I scroll through this list, unless something didn't work, it actually, there we go, it's catching up. It was scrolling through the list for me. I swear it was better before. Well, unfortunately, you may have to trust me for that. There. Well, that is how you would define the virtualization. And I did this earlier. I could actually scroll through the items, and it is dynamically loading in the elements on the screen. It's doing a little bit better here, but it's not as good. It actually really was running a lot better earlier, so I wish I could tell you it was perfect here. But you can see I'm at least now getting some scrolling. So you see there's a difference in the behavior going on here. And what that did is that Ionic just takes care of that for you and knowing how to take those items and dynamically load them into the application for me as I scroll through the list. So I didn't have to think about implementing that code, which again is not a trivial thing to do. Another thing worth calling out while I'm in the Cordova Tools extension here is if I show you real quick, let's say we wanted to debug our TypeScript code. I could come in and let's just pick something, say, even after the application first loads up this screen. So I've set a breakpoint on my code, and if I switch between some screens, I may have a big problem with the amount of data I've got this time around, right? We'll just destroy that application, relaunch it. So our extension with VS Code will let you put in breakpoints, and it attaches the debugger up so that, okay, in this case I think I quit the app and I lost my debug connection, so I won't try that demo. But it gives you, it'll stop at the breakpoint and let you explore your variables, set up watches, and do things like you're used to doing in a debugger, just right from within the VS Code editor. Okay. So when we looked at virtualization, we looked at this a few years ago, and at that time we worked with another framework, Win.js. And in our test there, we had, I forget if it was 30,000 items we went through, but the memory used by a virtualized solution was like 98 megabytes versus 333 megabytes using a non-virtualized solution. So it had some big benefits on memory, the performance of the app as you scroll through items when it's used, apparently when your demo works out for you. So another interesting point in time optimization right now you can look at doing is, this is about swapping out the web view used by your iOS application. So in iOS, there's actually two web views. There's a UI web view that's been in iOS for a long time, and then there's the newer WK web view that Apple introduced a while ago. It's what Safari uses, and it's what they're actively updating now with each iOS release. So the Ionic team has made it possible through a plugin to swap in that WK web view for your application to use. So the conference app we were using a moment ago, it's using that WK web view. The Ionic team is going to work with Cordova to see about bringing this in. So beyond it just being updated and being the latest thing that Apple's working on, it brings a lot of improvements for performance. It works with the newer Nitro JavaScript engine, so you have quicker executing JavaScript on your iOS device. The Ionic team, when they worked on their conference app, they said that just by using that alone, it took down their memory by about 20 megabytes. So it's really worth looking at. The issue and why it's not in Cordova right now is, if you're curious, CORS, something used for security with your web apps, CORS wasn't working well in Cordova with WK WebView. They've done some fixes with this plugin right now, and they're comfortable enough using it in some of their demos and asking people to try it out for them. So another general recommendation would be about working with the network. So you'll remember on these devices, you're working on cellular networks, places that the connectivity is not going to be as fast as running on your laptop, for example. So you want to be sure and do some common best practices around working with services. Batch your requests, use pagination, but also limit the number of requests you're sending to a server. I like some tricks if you're going to be serving images from a server. Take some time to understand what's the screen size and the resolution of the device that's accessing your solution, and have it dynamically serve up images that are a better fit for that device, rather than sending down really large images and then scaling them on the device. Tricks like that you want to consider to help out. Every little bit can help on these connections. Sometimes also don't forget that it can be an intermittent connection, and you have to think of things like offline and using some of the tools out there for offline connectivity and offline caching of data. SQL has the ability to work with there's a few protocols. There's one like WebSQL as a standard you can use for some local SQL interactions. Cordova has a plugin that lets you work with SQLite when the native web platform doesn't already support that. So you can use a technique like that in your application to write to a local SQL storage or write to the even more simple local storage that is available to web applications. Testing in both dev and release modes. This one, when I was running in Ionic and I did Ionic Serve, as I was playing around and looking at things, I found that what they do when you do Serve is it's actually a dev build of the code. So it has some stuff in it that they don't have to minify the code the same way. That means they can basically leave your code alone a little bit after it comes from TypeScript and not bother with some optimizations that don't benefit you so much at dev time. Do things to support live reload, so in the browser it can dynamically refresh content. But that leaves other bits and stuff in your code that make it not run as fast as it could. So when you do a build for release mode, they're able to do more optimizations, shrink that code up more, take advantage of things like the ahead of time compilation in Angular that will speed up your app. So you want to test in both configurations. That release mode is what you would want to distribute to your users, and you want to be sure that's performing okay from a performance perspective, meeting your expectations. I'll also say it's a good idea to run a performance audit of your own app using browser developer tools. So you want to use these tools to help diagnose your app. You can look at things like your memory usage, CPU usage, and even monitor frames per second. So if you weren't familiar with that, let me show you real quick, for example, how you would look at something like frames per second. Let me bring up this guy over here. I always love these demos because I got a lot of devices I go through, and so it's like switching between different ones. We'll keep it simple and we'll look at, I'll bring it up on the screen here in a moment. We'll just use a browser developer tools in the browser. So you can do some monitoring. Let's use Chrome specifically. So here over in Chrome, I can bring up the developer tools. And if I zoom in here for you, in these developer tools, I can do some things like watching in this timeline. I can monitor a few things. I can come down and let's take a look at my rendering settings. And I'll just show you in the web browser testing this, but you can actually do it for a mobile device too. I'm going to scroll down, and that opened up another pane down here with my rendering settings. And you can bring up a frames per second meter. And so now here in my website, I'm going to zoom in again, you see frames per second being tracked, and it's showing me, how's this working for this page. So as I scroll the page, you can monitor what's happening with the transitions. And you'll see in the browser, it stays close to that 60 frames per second. I can also go, and I could take and go into the tools. Oops, let me find the right button. And inspect devices. And in this case, I've got my Android application running here. Slightly older device, it may not perform as well, but I can pick, which one do I have open? I think this is the one. If I say inspect, let's make sure this is the right looking app. Is this the one on my screen? No. Let's pick this one. I can see the application that's running on my device screen, and I can do some debugging here in the browser tools actually with the Chrome dev tools if I wanted to. Work with the DOM, do some other functionality, look at the console. But from that performance perspective, I can also come in here and bring up again the frames per second meter on my device. And so I'm seeing it on this screen here. You're not seeing it on that one, but as I scroll through, it's showing me a similar reading of the frames per second. I think I can actually show that to you through here. So yeah, so you see the frames per second meter there. Again, a slightly slower device. We're staying in a different range of performance. We're not exactly hitting the 60 frames per second, but it keeps baselining pretty well as it goes through these transitions. So you can do some other lower level debugging there if you want to. Separately, just using those Chrome developer tools, if you didn't know about the inspect devices option, that's really handy in mobile website development as well as mobile apps. You can attach to that web view running on your Android device, for example, and do some things. Safari also has the ability to do their web inspector to inspect things remotely if you haven't used that before. Any questions on that one real quick from the browser developer tools? We can come back around on some of the other items there too that we talked about. So testing, again, is also a very important thing, really. You're in development mode, you're cranking away maybe on your 8-core, 30 gigs of RAM Mac on your desk, or it's not going to compare to the devices your users are using. So you want to be sure that you have some devices you're testing with. I'm fortunate enough to be able to get devices that we can test on and work with physical devices. That can be great to have these physical devices so you're seeing the real performance characteristics of the people in your enterprise or what you think your customer base is going to look like for your app. So trying the app out and even getting a feel for it yourself and seeing if it, subjectively, does it feel okay. You can also do things like some automated device testing with the Xamarin Test Cloud service. I know you may not think right away Xamarin and Cordova, but Xamarin's Test Cloud has the ability to run automated tests against a suite of real devices, and you can actually use non-Xamarin applications there, Cordova included, and do some scripting with a thing called Calabash and a tool called Cucumber that let you write some automated tests to go on these devices. And you can do some performance testing where it's more like stopwatch timings of certain things for some very simple performance benchmarking doing that. As far as testing with your real users too, you could take a look at the Hockey app service. That allows you to take, say, your APK for the app for your Android application and push it out to a set of beta test users through Hockey app. And then your real users can be beta testing that application using Hockey app to give you feedback as they go, and that's another good way to get some feedback about the performance. Is it meeting people's expectations about the user experience? Generally also just follow some best practices out there for web performance. I've got a few links here to some things. One article on writing fast, memory-efficient JavaScript. This is by a guy named Adi Asmani that some of you may have seen out on the web over the years. He's got a lot of great content around JavaScript and web standards. It's an article that's been around for a bit. It's got a lot of great tips that I think stand the test of time for JavaScript development. There's our performance talk again from build 2015 that goes in depth on those items at the start. And it goes through the methodology we used in testing, the devices that we used, and how we took the kind of the scientific method of looking at these long-held assumptions about performance and Cordova, and went in with some hypotheses and tested them out, ran several iterations, and kind of came to some conclusions and shared them out in that session with a lot of great videos showing the exact tests we run, how we came to our conclusions, and then a lot of an example of bad code, good code, and what you should, don't do this, do that type of stuff. And then there's another one I found, top 10 performance techniques for your hybrid apps. This is a good one. This is a bit old, but it also had some great stuff around PhoneGap and Cordova in general, like performance. And then for tools you can get today, Ionic 2 and their RC, they've pushed out their release of Ionic 2 last night. They're going to have a blog post. I didn't see it right before this session, but they told me one is coming, so they're going to be announcing this very soon. Visual Studio Code has support for Ionic 1X and some for Ionic 2. I showed you a little bit there. We're going to have to build out some more, do a little more work there to run with snippets in Ionic 2 specifically, flesh out some details. But it supports debugging Android and iOS devices right from in Visual Studio Code. Visual Studio 2015, it has built-in support for Cordova development today. We have templates you can use for Ionic that you can get through the Visual Studio Gallery. And using those, you can debug on Android, Windows, and iOS devices, all from in Visual Studio. You can target emulators, you can do your development in a web browser, and you get the same debugging tools and diagnostics tools all from within Visual Studio without having to learn all the different browser developer tools for different devices. We're bringing that all together for you inside of Visual Studio.
Does it require a specific version of, like, say, specific flavor? Like, do you have the Enterprise Edition?
Good question. Yep.
Enterprise edition or anything like that to work with it?
Good question. So your question was, do you need any specific version of Visual Studio to work with this, like Enterprise or Professional? You can get this in Visual Studio Community, the free edition. All the SKUs include support for it. Our Visual Studio Code extension, too, is just freely out there if you want to use it. We didn't touch on these other two technologies, but there is stuff for Cordova and Ionic in this space, so I'm going to hit upon them. Visual Studio Team Services. If you're not familiar with that, they support source control, work item tracking, automated builds, all within a centralized service that's similar to Team Foundation Server in the past you may have used. It's more of an on-premise solution. We've got Visual Studio Team Services in the cloud, and we've got pre-made build definitions for working with Cordova. So I can set up my automated build and have tasks in there to actually run Cordova commands, and it can build Android, Windows, and iOS applications as part of my automated build and push out those IPA, APK, or AppX files for me. I can integrate that with some extensions also for Hockey App, and I can actually have a build run, build my Cordova application, like take that APK and distribute that update through Hockey App and immediately roll it out to my beta test users if I want to. It's kind of a fun workflow that you can configure. If you use iOS, you need to bring your own Mac. That is the same for any of these scenarios. You need to use, for iOS development, you need to have a Mac being used with Xcode to build for that platform. And so you can set a Mac Mini off in the corner to take care of that for you and set up the build agent with Visual Studio Team Services to use it. Or you can look at some services out there. There are some that are like Rent-A-Mac services. You can go online and basically buy some time with a Mac that is used for your purposes to do things like builds as an option. The question is, doesn't Xamarin do that? So as in like their own build services?
Yeah, don't they provide a build service for Macs?
They don't have one for, not for the Mac, no, you'd use another solution there. And Code Push, that is a service we've got that takes advantage of, so there's a benefit that JavaScript has in the app stores that's totally allowed. You can dynamically update the content of your app as long as it's using JavaScript. In the Apple App Store, Google Play Store, other apps, you're not allowed to push out updates of like your binaries without going through the app stores. With JavaScript content, as long as you're not changing the purpose of your application, you're okay to push out updates out of band. If you think of it like if your app's referencing web content, it may just be pulling new content from a web server, and that's still supported for an iOS application. Code Push leverages this and gives you a service that through the service you can push your changes through Code Push and it gives you APIs you can use to interact with this service and bring down updates for your users dynamically into your application. So it would work in apps that go through the app stores, apps that go through your own local MDM solution. And that is everything I had to go through for everybody today. Kind of a whirlwind of stuff there, so I am more than open to any questions you may have or other discussions you guys would like to have. I'm down at the Mobile Development and Xamarin booth this week. Here, if you guys have any feedback for me, I'd love it. I'm actually getting ready to do a run of presentations in the weeks ahead here, and I'd love to bring any of your feedback into that and get better at speaking. So thank you for the time.